Take 1 minute time to write the problem. What is the given thing here? An unsymmetrical I section builds girder as the following sectional properties. Cross sectional area is given. Okay. Second moment of area is given. Width and thickness of top plane 1200 by 360. Thickness of web is 540. Then center of the section is located at 580 mm from the top. Girder is used over a span of 40 meter. Okay. It is a unsymmetrical I section. Let me write the figure of a unsymmetrical I section first. Okay. Write the figure of a unsymmetrical I section like this. Okay. Also draw the neutral axis. Neutral axis. Now go through the problem. The area of cross section is 777 into 10 power 3 mm square. Area of cross section is given. A is equal to 777 into 10 power 3 mm square. Then moment of area. Second moment of area, that is moment of inertia, is given as 22 into 10 power 9 mm to the power 4. Moment of inertia I is equal to 22 into 10 power 4 millimeter raised to 4. Then width and thickness of top flange is 1200 and 360. 1200 mm and 360 mm. 360 mm. Okay. Then and the thickness of web is 240 mm. Thickness of the web is given as 240 mm. 240 mm. Then what else is given? The center of the section is located at 580 mm from the top. The distance of centroid is at a distance of 580 mm from the top. 580 mm from the top. The girder is used over a span of 40 meter. Span L is given as 40 meter. Okay, or 40,000 millimeter. Okay. The tendons with the cross section of 700 mm square. The cross section of the pre-stressing wire is given. Area of cables or area of tendons is given. Area of tendons is given as 700 mm square. 700 mm square. Parabolic with an eccentricity of 1220 mm at the center of the span. Okay, it's a parabolic cable. Eccentricity is 1220 mm at the center of the span and 0 at the supports. 0 at the supports. The effective pre-stress in the wires is 800 Newton per mm square. Pre-stress is given. Pre-stress is given as how much? 800 Newton per mm square. Okay. Pre-stress in the wires is given as 800 Newton per mm square. If the tensile strength of the concrete is 4.5 Newton per mm square, Ft is equal to 4.5 Newton per mm square. Okay, tensile strength of the concrete is represented by the sign Ft. Estimate the ultimate shear resistance. Ultimate shear resistance is asked of the section, assuming failure to take place when the principal tensile stress reaches a value equal to the tensile strength of the concrete. Okay. So to find this ultimate shear resistance or the ultimate shear force, I have shown you the formula in the beginning. That is Vu is equal to let us take it as Vu. Okay, Vu is equal to Vw into I by S into root of Ft square plus FCP into Ft, okay, plus P sin theta is the formula. P sin theta means shear force due to the pre-stressing force. Okay, P sin theta is nothing but shear force due to the pre-stressing force. Now we'll calculate one by one. Bw is means width of web. It is given as 240 mm. Bw is equal to 240 mm. It is given in the problem. Then what else is required? Moment of inertia I. It is also given in the problem. How much it is given? 22 into 10 power 4. 22 into 10 power 4 mm to the power of 4. Moment of inertia. Then S is nothing but starting moment of area. Nothing but AY bar. Static moment of area, which is equal to A into Y bar. I'll call it as A, small AY bar. Okay, capital A means I will treat it as area of the full cross section. Okay, small A into Y bar. So S is equal to static moment of area of the shaded portion above the neutral axis. So moment of this whole area, okay, about the neutral axis, you need to find. Okay, now you divide this shaded portion into two rectangles. You divide into two rectangles. One is flange 1200 by 360 and width of 240 by the what will be this length? 580 minus 360. How much will get? We'll get it as 220 mm. 220 mm. Okay, so I have divided this shaded portion into two rectangles. Okay, first you find the moment of this flange 1200 into 360 into distance of center of flange from the neutral axis. So S is equal to, I am finding moment of flange 1200 into 360 AY bar. 1200 into 360 is the area of the flange. Into Y bar. Y bar is nothing but distance of center of this flange from the neutral axis. How much it will be? It will be 220 plus 360 divided by 2. Okay, this is 360 by 2 means 180. 220 plus 360 by 2 right here into 220 plus 360 by 2. Okay, so you got moment of flange about the neutral axis. Now you calculate the moment of portion of web about the neutral axis. The cross section of the web is 240 by 220. Area plus 240 into 220 into distance of center of the portion of web from the neutral axis. It will be 220 by 2. Okay, it will be 220 by 2. 220 by 2. Okay. By this, you will get the static moment of the area. Okay. Cross check the answer. It is 178.61 into 10 power 6 mm cube. Okay, 178.61 into 10 power 6 mm cube. Okay. Okay. Then FCP is equal to means stress in the concrete. FCP is equal to stress in the concrete due to pre-stressing force is equal to P by A is the formula. P by A is the formula. Pre-stressing force, it is not directly given, but the stress and the area of the tendons is given. Area of the tendon is given. Pre-stress in the tendon is given. Area multiplied by stress will give pre-stressing force in the tendon. Correct. Therefore, P is equal to pre-stressing force is equal to stress multiplied by area of tendon, not the full cross-sectional area. Okay. Stress in the tendon is 800 and area is 700. 800 into 700. The answer that I get is 560 into 10 power 3 Newton. Okay, P is equal to 560 into 10 power 3 Newton. Okay, therefore, FCP is equal to P substitute as 560 into 10 power 3 whole divided by cross-sectional area. How much is the cross-sectional area? 777 into 10 power 3 mm square. 777 into 10 power 3. Okay. FCP, you will get it as 0.72 Newton per mm square. 0.72 Newton per mm square. Okay. Now you got the value of FCP. FT is given in the problem only. How much it is? 4.5 Newton per mm square. FT is equal to 4.5 Newton per mm square. Then what else is needed? We need the value of sin theta. Correct? We need the value of sin theta. We know the formula for parabolic cable. For parabolic cable, the value of slope sin theta is equal to 4e by L. 4e by L. Okay, 4e by L. So 4 into eccentricity is given. How much it is? 1220 mm. 1220 mm divided by length of the beam. How much it is? 40 meter. So in terms of millimeter, 40,000 millimeter. Okay. So finally, you will get the value of slope as 0.122. You get the value of slope as 0.122. Okay. And now we got all the parameters, required parameters to calculate the shear force. Correct. Just substitute. You can call this as equation number 1. Therefore, equation 1 becomes. Equation 1 becomes VU is equal to BW. BW is 240 into I by S. 240 into I is how much? I is 22 into 10 power 4. 22 into 10 power 4 divided by S. S is how much? 178.61 into 10 power 6 into 10 power 6. 10 power 6 I by S into root of FT square plus root of FT square. FT is 4.5. It is given in the problem. 4.5 square plus FCP into FCP 0.72 into FT again 4.5 plus P sin theta plus P sin theta. P is how much we got? 560 into 10 power 3. 560 into 10 power 3 into sin theta value is 0.122. Okay. Now you can calculate the answer. The final answer that you get is ultimate shear resistance that you get is 211.54. Sorry, it is 59. 211.59 into 10 power 3 Newton. Okay. Or V is equal to 211.59 kilonewton. Okay. So this completes the problem. Okay. Any doubts if you have, you can ask. So very simple problem it is. Just you need to remember this formula. Okay, one by one parameters, all the parameters you need to find. Finally, if you substitute values of all the parameters in this equation, you'll get the required answer, ultimate shear resistance. Okay, thank you.